SMIC just beat Intel on the one metric that defines how advanced a chip factory is: minimum metal pitch. 32.5 nanometers versus Intel's 36, without a single extreme ultraviolet machine. But here's the problem: the chip that carries that number is still 38% behind Intel on the metric that actually matters: transistor density. One measurement says China just passed the West, another says it hasn't even come close. And the difference between those two numbers tells you more about the future of semiconductor sanctions than any policy paper ever will. And what happened next is exactly why a brand new teardown lab exists. On June 14th, SemiAnalysis published the first report from its new in-house teardown facility, STEEL, the Teardown Engineering and Evaluation Lab, built in Hillsboro, Oregon. The chip under the microscope was a high-silicon Kirin 9030 Pro pulled from a Huawei Mate 80 Pro Max. This wasn't a leak or a rumor. It was physical reverse engineering, cross-section imaging, metal pitch measurement, transistor counting, layer by layer, and the numbers that came out rearranged the scoreboard between China and Intel in both directions at once. Tom's Hardware independently covered the findings 2 days later, confirming the same data points. Tech Insights, the industry's other major teardown firm, published its own analysis the same week and reached a matching conclusion. The chip is built on SMIC's N+3 process. But to understand why one number looks like a win and the other looks like a wall, you need to know what metal pitch actually measures and why it is not the same thing as transistor density. Metal pitch is the distance between the finest wires inside a chip. Smaller pitch means the factory can print finer details. It is the clearest single indicator of how advanced a lithography process is. Intel's 18A shipping inside Panther Lake laptops right now runs at 36 nanometers. SMIC's N+3 inside the Kirin 9030 runs at 32.5 nanometers. That's 10% tighter. And SMIC did it using only DUV, deep ultraviolet lithography machines, that the industry considers a generation behind. No extreme ultraviolet lithography, no ASML NXE scanners. The technique is called self-aligned quadruple patterning, or SAQP. Instead of printing a pattern once with extreme precision, you print it 4 times with older equipment and stack the exposures. It works, but it costs more, takes longer, and introduces cumulative alignment errors with every pass. To put that in perspective, a single ASML EUV machine costs around $380 million and uses 13.5 nanometer wavelength light to print patterns in a single exposure. SMIC's DUV machines use 193 nanometer light, 14 times coarser, and compensate by printing the same layer 4 separate times. Each pass introduces risk. Overlay accuracy, edge roughness, and defect rates all compound. The result is a process that can match EUV on raw resolution in certain layers, but pays for it in cost, complexity, and yield everywhere else. That's where the second number comes in. Transistor density, how many transistors you actually fit per square millimeter, is where SMIC falls behind. Intel 18A packs roughly 183 million transistors per square millimeter. SMIC N+3 reaches 113.4 million. That's a 38% gap. The reason is architectural. Tight metal pitch alone doesn't shrink the transistor cells. Intel uses a different transistor structure, RibbonFET, its version of gate-all-around, combined with backside power delivery. SMIC is still on FinFET, the previous generation of transistor architecture, and delivers power from the front side. Tighter wires, same-sized rooms. Now here's where the verified data and the open questions start to diverge. 2 independent labs measured the same silicon and reached the same conclusions. SemiAnalysis, from direct cross-section imaging, put SMIC N+3's minimum local metal pitch at 32.5 nanometers. Intel 18A ships at 36, verified from Panther Lake Silicon Tech Insights, publishing its own teardown the same week, called N+3 a scaled extension of SMIC's existing 7-nanometer technology, falling somewhere between 7 and 5 nanometers in real-world capability. Both labs confirm the process uses DUV only lithography with aggressive multi-patterning. On transistor density, SemiAnalysis measured 113.4 million per square millimeter, just above TSMC's older N6 node at 107.7 million. Not 5 nanometer, N+3 is a stretched, optimized version of SMIC's 7 nanometer family, not a generational leap. 3 numbers that remain unverified. SMIC has not disclosed yield rates for N+3. Multiple industry analysts estimate they remain significantly below TSMC and Intel, but no confirmed figure exists. The cost per wafer on N+3 compared to TSMC N6 is unknown, though the quadruple patterning process is widely understood to be substantially more expensive per layer. And whether SMIC can scale N+3 beyond smartphone chips into AI accelerators like the Ascend series has not been confirmed by any source. This chip is commercially available and it is inside the Mate 80 Pro Max, which you can buy today in China. But its performance tells a different story. In Geekbench 6, the Kirin 9030 Pro scores roughly 320% lower in single-core performance than Qualcomm's current Snapdragon 8 Elite. Its CPU performance sits closer to Android flagships from 2021. The process is real. The product is shipping, but the competitive gap in actual performance remains wide. The companies watching these numbers most closely have already responded. On May 21st, NVIDIA CEO Jensen Huang told CNBC that NVIDIA has largely conceded the Chinese AI chip market to Huawei. He described Huawei as very, very strong and said the domestic ecosystem is growing because NVIDIA has evacuated that market. China once represented over 20% of NVIDIA's data center revenue. That share has now collapsed to near zero. Huang told investors to expect nothing regarding approvals to sell advanced chips back into China. Intel, meanwhile, is shipping 18A in Panther Lake, its first commercial product on the node. But Intel is watching the pitch number closely. A Chinese fab matching or beating Intel's minimum metal pitch without EUV undermines one of the core assumptions behind export controls, that cutting off EUV access would freeze Chinese manufacturing at 7 nanometers indefinitely. SMIC shares surged more than 18% after Huawei's logic folding announcement on May 25th. Huahong, another Chinese foundry, hit its daily limit of 20%. The Star 50 index in Shanghai, which tracks major Chinese chip firms, rose to a record high the same day. Huawei has its own answer to the density gap. At IEEE-ISCAS in Shanghai on May 25th, Huawei's semiconductor chief He Tingbo unveiled logic folding, a 3-dimensional stacking architecture that folds circuits vertically instead of shrinking them horizontally. Huawei claims a 53.5% density increase for the upcoming Kirin 2026 chip, reaching 238 million transistors per square millimeter. That would put it on par with TSMC's 3-nanometer process. The first logic folding chip ships this fall inside the Mate 90 series. But no independent lab has verified those density claims yet. The market moved before the full picture was clear. So what does this actually mean for you? Prices first. The Kirin 9030 is only in Huawei devices sold primarily in China. It does not directly affect the price of laptops or GPUs you buy in the West. But indirectly, it matters. If SMIC can produce competitive mobile chips at scale using only DUV, it reduces China's dependence on Western fabs, which means the global supply chain splits further. A more fragmented supply chain historically raises costs for everyone, not lowers them. Availability. You cannot buy SMIC N+3 products outside China in any meaningful way. The Mate 80 is available in China and select markets, but not in the US or the EU. The real availability question is whether N+3 scales beyond phones. If SMIC applies N+3 to Huawei's Ascend AI chips, particularly the upcoming 950DT, a training variant expected in the fourth quarter of this year, that changes the compute capacity inside Chinese data centers, and that changes the AI race. Huawei's logic folding Kirin 2026 chip is expected this fall inside the Mate 90 series. If the density claims hold up under independent teardown, it would be the first time a Chinese chip reached TSMC 3 nanometer class density. But that chip has not shipped yet, and until it does, it remains a slide deck, not a product. Investment implications. SMIC shares rose more than 18% after Huawei's logic folding announcement in May. Intel is trading under sustained pressure as it ramps 18A and faces margin compression from aggressive fab spending. The SemiAnalysis teardown did not move markets on its own, but the data it produced feeds directly into the analyst models that price these stocks. ASML, which makes the EUV machines SMIC cannot buy, closed at record highs in June, partly because every teardown that shows DUV reaching its limit reinforces the long-term demand for EUV. If you hold positions in Intel, TSMC, or ASML, the question is no longer whether China can make advanced chips without EUV. The question is how far they can go before the physics of DUV finally stops them. Here's my read on what this actually changes and what it doesn't. SMIC beating Intel's metal pitch is real. It's not a cherry-picked number, it's measured silicon verified by 2 independent labs in the same week. But it doesn't mean SMIC has caught Intel. Metal pitch is one dimension. Transistor architecture, power delivery, density, yield, and cost are 5 others, and SMIC trails on all of them. What this teardown actually shows is that export controls changed the optimization problem. They didn't freeze China at 7 nanometers. They forced SMIC to push DUV lithography harder than anyone thought possible and hit a ceiling that is real but higher than predicted. The 38% density gap is still a gap, but 3 years ago, most analysts assumed SMIC would never get past N+1. They're on N+3 now. The question isn't whether China is behind, it's how fast that distance is closing and whether the tools to stop it still work. SMIC beat Intel on metal pitch using only machines the West considers obsolete. Does that mean sanctions are working or that they've already failed? Drop your answer below and tell me, how many years does China actually trail the West right now? If you want verified semiconductor analysis before it hits the mainstream, subscribe to Silicon Brief.